So now that we know this is a DP problem, we have set up our initial table, we've put the base cases, we've defined what LCS of I of j is going to be. The next step obviously is to define optimal substructure. So to quickly recap, in case you don't quite remember from the last class, optimal substructure is the formula for filling in the values of the table. It tells you how the solution to problem of size n is connected to the solutions to size n-1, n-2, whatever. So for every DP problem there is a specific logic. Based on that we define the optimal substructure. So here the base case of course is the LCS of any sequence with an empty sequence, which we already discussed when setting up the initial table. So even if one of your two strings is empty, then obviously the length of the longest common subsequence is 0. So LCS of I of j is going to be 0 if either of the sequences is empty. This is a straightforward thing, which is why we inserted a 0 row and column to account for the same. Now going further, we compare the jth character of sequence 1 with the ith character of sequence 2 at each iteration. So when you want to fill in the column LCS of I of j, you will compare those two characters. So I'll go back to the table and explain. So we took this cell as an example, right? A along sequence 1 and C along sequence 2. So I said it is the longest common subsequence between BDCA and ABC respectively. So when you want to fill in this column, what you will do is you will check this character from sequence 1 and this character from sequence 2. Now if both of these characters are the same, it means they are part of the longest common subsequence. They can be, most probably. So that means the length of the longest common subsequence should be incremented by 1 because you have one matching character. So in that case what happens is your solution becomes 1 plus longest common subsequence of I-1 characters of sequence 1 and j-1 characters of sequence 2. So let me repeat myself. When you want to fill in the I, j the cell of a table, you will look at the corresponding characters along the row and column. You will see if they are the same or they are the different. So if both the characters are same, if the sequence 1 character and sequence 2 character corresponding to this cell are the same, it means they are part of the longest common subsequence. So the length of the longest common subsequence needs to be incremented by 1 because this is one common character we have found out. So the value here, as you know, which has to be the length of the LCS up to this part, should be 1 plus length of the longest common subsequence up to the previous character of sequence 1 and up to the previous character of sequence 2. So this will become 1 plus this value if these two cells are equal. So that is what we have given here. If the jth character of sequence 1 equals the ith character of sequence 2, your value is just 1 plus LCS of I-1 of j-1. So for example, let's say you take this cell. So it's a D over here and a D over here. So there are two Ds. So this D is going to be a part of the longest common subsequence between BD and ABCBD. So it becomes 1 plus this value. That's the case if your corresponding row and column characters are the same. So that was the case if the corresponding row and column characters are both the same. If they are not the same, now you have two alternatives which you compare and you have to choose the maximum. So if you remember in your coin change problem, when you were filling in the grid, there were two alternatives: pick the coin, don't pick the coin. You chose the max. The min, because it was a minimization problem. Now this is also an optimization problem, and so far we have not come across any max or min terms here. So this is where the max or the optimization part actually comes in. So if both the characters, like I said, if they are same, it's a pretty straightforward job. If they are not the same, what you will do is you will compare the cell above and the cell to the left. So let's say again we'll come back to this cell, which is what we've been working with. A and C, as you can clearly observe, are not the same character. So you will look at this cell and you will look at this cell. So this is dp of I of j, this will be I-1 of j, and this will be dp of I of j-1. So you look at the one immediately above, you look at the one immediately to the left, you will compare both. Whichever has the greater value, you will simply take that and copy it here. Now why do we do that? So this is because So when you are first trying to fill this grid, what you're doing is comparing the ith character of sequence 2 and the jth character of sequence 1, and they are not equal because we are discussing that case now. But it could be possible that the ith character of sequence 2 is equal to the j minus 1th character of sequence 1, the immediate previous, or vice versa, the jth character of sequence 1 is equal to the I minus 1th character of sequence 2. So if you look at this logarithm example, I think there is one yeah, if you do the LCS for these two, you will notice. So here if you look at the you take algorithm and logarithm, assume these are the words. You just take the first character of each, A and L respectively. They do not match, so they are not equal. But if you take the first two characters over here and only the first character here, there is an L and there is an L here. So the LCS of Al from algorithm and L from logarithm would be the letter L. So there is one character. So the point I am trying to drive home is, you compare the ith and jth. If they do not match, you have to compare the I minus 1th with the jth, and similarly the j minus 1th with the ith, because there could be a match. And you will compare those two. Whichever is the greater of those two, you will fill that into the box, because obviously this is a maximization problem. So our LCS is defined as 0, of course, if either of the sequences is empty. If the ith and jth characters of the two sequences match, it is 1 plus LCS of I minus 1 of j minus 1. In other words, 1 plus the top left cell. If they do not match, you have to compare these two, LCS of I of j minus 1, which will be the immediate left, and LCS of I minus 1 of j, which is the immediately above grid. You compare those and you fill in the max. So that is our optimal substructure.